So today we're going to talk about parametric equations. Objective, parametric functions, parametric equations, but before officially introduce them, think about it this way. Suppose you have an object, that object is moving in the space. Well, here you have an object in the plane, in the space. Okay. This object can be identified by its position in the plane, in the space, and the position is denoted by an ordered pair x, comma, y. Okay, this is my point representing the position of this particle or this object. You might be interested in, okay, at time t, where this guy is located, what's the position of this particle at time t? This is a legit question. You should be able to ask this question and try to answer this question by assigning a new variable. So, question is how to assign a new variable. In this simple example, you have a particle, you have the position of the particle. Okay, but how can I connect the position to the time? At time t, this particle is here. This new variable, like time, like t, is called the parameter. So this new variable is a parameter. Well, you're trying to connect the position with this new variable like t. What are you going to do? You're going to depend x to t and at the same time y to t. So instead of just writing x and y, we're going to write this as x of t and y of t. This way, we are representing a new variable like t, and we are connecting x and y to this new variable. So x depends on t, y also depends on t. In physics, in engineering, you might be interested in connecting the position to the heat. There are different variables, different parameters that you're interested in working with. You might be saying that, hey, why not connecting x and y into the time and heat at the same time? So there, you're going to introduce two new variables, two new parameters, especially in Math 1D, you're going to see you have x of s and t, y of s and t. You can introduce as many variables, as many parameters as you like. So officially, we say, hey, we can define a parametric curve. Parametric curve. So suppose x and y, let x and y are given as functions. You are depending x and y to a new variable as functions of a new variable, a new parameter like t. We write them this way. X is f of t and y is g of t. If you open different calculus books, you might see x of t, y of t, or x is equal to f of t, y equals to g of t, or many other functions like h, like I. So instead of f and g, we can use different functions as well. So x is a function of t, depends on t. Y is a function of t, depends on t. Then the set of points, x and y, depending on t, in the space, in the plane, these are representing the position of particle. You can graph them. Forms a curve in the plane or in the space. The set of points defined by these equations what equations? F of t and g of t is a parametric curve. So this is the official definition. Give us an example. Okay. One example that we saw before is depending x to t, y to t using trig functions. So let x be equal to cosine t and y be equal to sine t. So as you can see, we're using trig functions here. Let t be bounded between 0 and 2 pi. So in a sense, you're working with angle. T can be represented using theta that you saw before, and theta or the angle is bounded between 0 and 2 pi. Question is, what does this guy represent? The curve is, okay, take a look at this. Your x is cosine, your y is sine. What do we know? We learned in pre-calculus that, recall that in pre-calc, you have sine squared plus cosine squared, which is always 1. Sine squared theta, cosine squared theta is always 1. You know that. You remember that. You learned it before. Here you have cosine, here you have sine. Why not raising both sides to the second power? Maybe we can get rid of this variable, this theta. Well, x squared is equal to cosine squared t, and y squared is equal to sine squared t add them. Add x squared and y squared, which is equal to sine squared plus cosine squared. So add these. X squared plus y squared is cosine squared plus sine squared, which we already know this guy is equal to 1. So what do we have? We have x squared plus y squared equals to 1. You already know that this guy represents unit circle. Unit circle. Well, okay. So see what happened here. Here we have x depending on t, y depending on t. We wrote a new equation that doesn't have any t in it. From parametric form into rectangular form. This is in parametric form into rectangular form. And it doesn't have any t in it. And you already know how to graph this guy. This is unit circle. Just note that when t is equal to 0, your x is equal to 1 and your y is equal to 0. So 1 and 0. Starting at this point and just rotating once. So your particle, your object, whatever it is, started at this point and start rotating counterclockwise, and it stops at this point. It doesn't rotate twice. It doesn't rotate 3 times or so on. It just rotates once counterclockwise.